Welcome to all my students in the radio Pathshala class. Today I am going to start the area of triangle and quadrilateral. The area of triangle and quadrilateral. We have already learned how to find the area of triangle, rectangle, square, rhombus, parallelograms. Now I am going to review the area of these geometrical figures. First of all, triangle. This is a triangle ABC. In this triangle, suppose a perpendicular is drawn from the vertex A to the base BC. AP perpendicular is drawn from the vertex A to the base BC. Then AP of triangle ABC, this AP line is called the height of this triangle. It is denoted by H. It is the height of triangle ABC and BC is the base. This is the base. The side on which we draw the perpendicular is called the base. Here we have drawn AP perpendicular to the base BC. So BC is the base. Let's look another triangle. In this triangle, ABC triangle, if BQ perpendicular is drawn on the side AC, then BQ is the height. BQ is the height, and in this case, AC becomes the base of this triangle. We suppose AC is the base. Now, if we have height and base of a triangle, then the area of triangle is area of a triangle A equals to 1 by 2 base into height. To calculate the area of a triangle, we use this formula. Area of a triangle A equals to 1 by 2 base into height. In some figures, it is given this is the perpendicular. ABC is a triangle and CR is perpendicular to this line AR. In this case, it is the height of triangle ABC. It is the height of triangle ABC and BC is the base because it is also perpendicular. And in this case, BC should be parallel to AR. BC and AR are parallel, then RC is perpendicular on BC or it is perpendicular to AR. So RC is height of triangle ABC and BC is the base. So area of triangle ABC equals to 1 by 2 base BC into height RC. In this way, we find the area of triangle. Next, rectangle. 2 number, rectangle. We are familiar with rectangle. This is a rectangle. We know the opposite sides of a rectangle are equal, and at least one of its angle is right angle. It is the length and it is the breadth. In the rectangle ABCD, this AB is the length of rectangle and BC is the breadth of this rectangle. And its area of rectangle, area of a rectangle A equals to L into B, length into breadth. In this way, we find the area of a rectangle. Next, 3 number, square. Square is a parallelogram in which its all sides are equal and at least one of its angle is right angle. This is a square. In the square, all sides are equal, so we can suppose its sides by L. AB is L and BC is also L and CD is L and this is L. So area of a square, area of a square A equals to L square or side square, length of a side square. Next, parallelogram. Rectangle, square are also the parallelograms. Now, three number parallelograms. Parallelogram. A quadrilateral in which the opposite sides are parallel is called parallelogram. This ABCD is a parallelogram. Its opposite sides are parallel. If it has opposite sides parallel, then it is called parallelogram. Area of a parallelogram, area of a parallelogram A equals to base into height. Base into height. Base into height. Suppose this AP perpendicular is drawn from A to the side DC. This is the perpendicular. This is the height of this parallelogram ABCD. AP is the height of this parallelogram ABCD and CD is the base. And we can also suppose AB is the base because opposite sides of a parallelogram are equal. Next, this is also the height of this parallelogram CQ. CQ becomes also the height of parallelogram ABCD. This is the height of this parallelogram. Or we can also make the height of this parallelogram in this way. BR. BR is the height of triangle. BR is the height of parallelogram ABCD, because this BR is perpendicular from B to the side CD. So CD is the base and BR is height of parallelogram ABCD. It is the height. So area of a parallelogram A equals to base into height. Now in this parallelogram, its area equals to base. Base is DC into height, either AP or QC or BR. We can write any one, AP, base into height, in this way. Now next, 4 number, rhombus. Rhombus is also a parallelogram in which its all sides are equal. It is a parallelogram and its all sides are equal. This is a rhombus, A, B, C, D. Its all sides are equal. It is a parallelogram, so its opposite sides becomes parallel. Rhombus is a parallelogram having all sides equal. So area of a rhombus area of a rhombus A equals to base into height, because it is also a parallelogram. So base is BC. Here, if we have drawn the perpendicular from A to BC, AP is the perpendicular, then BC becomes the base. So area of a rhombus A equals to base into height, base into height. It is a parallelogram, so its area is base into height. In this rhombus, area equals to base, BC is the base, and height is AP. So BC into AP. And we can also find the area of rhombus by using its diagonals. Suppose there is a rhombus PQRS and its diagonals are given. This is one diagonal. Suppose it is D1. It is the first diagonal, and next is D2. This is the second diagonal. Suppose the next diagonal by D2. D1 and D2. First diagonal and second diagonal. Then the area of this rhombus, area of a rhombus A equals to half D1 into D2, first diagonal into second diagonal. Area of a rhombus A equals to 1 by 2 D1 into D2. In this rhombus, its area equals to 1 by 2. First diagonal is PR and second diagonal is QS. This. Now next, 5 number, trapezium. Trapezium. Trapezium is a quadrilateral in which its one opposite sides are parallel. A quadrilateral in which one opposite sides are parallel is called trapezium. This quadrilateral is a trapezium because it has one opposite sides are parallel. AD and BC are parallel. So it is a trapezium. And area of a trapezium area of a trapezium A equals to 1 by 2 into height. This is the height of this trapezium, this h, because AP is perpendicular from A to the side BC. This A is on this side AD, and AD and BC are the parallel lines. So AP becomes the height. This is the height, or this can be also the height of this trapezium. Let's say it is DQ. It is also the height. So area of a trapezium A equals to 1 by 2 height 1 by 2 height into sum of parallel sides. Sum of parallel sides. Sum of parallel sides. 1 by 2 height is h, and if we suppose the parallel sides by A and B, these two sides A and B, then it becomes 1 by 2 h into A plus B. A and B are the parallel sides of this trapezium. Next, kite. Kite. It is a quadrilateral whose adjacent sides are equal. This is a kite. Its adjacent sides are equal. This side and these sides are equal, and this side and these sides are equal. A, B, C, D. This is a kite whose adjacent sides are equal. BC equals to DC and AB equals to AD. This is one diagonal. Suppose it is the first diagonal of this kite. D1, suppose it is D1, and suppose it is D2. First diagonal and second diagonal. It is the shorter diagonal and it is the longer diagonal. And area of a kite, kite A equals to 1 by 2 first diagonal D1 into second diagonal D2. 1 by 2 D1 into D2. Next is quadrilateral. Quadrilateral. Suppose it is a quadrilateral ABCD. In this quadrilateral, AC is a diagonal and BD is another diagonal. Oh, only AC is one diagonal, and on this diagonal, this BP is a perpendicular on the diagonal AC. And next, DQ. DQ is perpendicular on the diagonal AC. In this quadrilateral, AC is a diagonal, and on this diagonal, two perpendiculars are drawn from other two vertices, B and D. BP is one perpendicular drawn from the vertex D to the diagonal AC, and DQ is another perpendicular drawn from the vertex D to the diagonal AC. Suppose it is first perpendicular P1 and it is the second perpendicular P2. Then the area of this quadrilateral, area of a quadrilateral A equals to 1/2 diagonal into sum of perpendiculars drawn from other two vertices to the diagonal. It means P1 plus P2. 1/2 diagonal into sum of the perpendiculars drawn on this diagonal. Now the students, now I will start the theorem 1. Theorem 1. The statement of the theorem 1 says that the parallelograms on the same base and between the same parallels are equal in area. This, it is the statement of the theorem. The parallelograms on the same base and between the same parallels are equal in area. What does this statement says? Look, parallelograms on the same base and between the same parallels. There are the parallelograms on the same base and between the same parallels. Suppose this parallelogram and this parallelogram. There are the two parallelograms. There are the two parallelograms on the same base CD. This parallelogram ACDE and the parallelogram FCDB are standing on the same base CD and between the same parallel lines AB and CD. These two parallelograms are standing on the same base. They are made on the same base CD. This parallelogram is standing on the base CD, and this parallelogram is also stands on CD. Both parallelograms are standing on the base CD. They are formed on the same base CD and between the same parallel lines AB and CD. In this case, the area of parallelogram ACDE equals to the area of parallelogram FCDB. Their areas are equal. The area of the parallelograms which are standing on the same base and between the same parallel lines are equal in area. The area of the parallelograms are equal if they are standing on the same base and between the same parallel lines. If the area of this parallelogram ACDE is 15 cm square, then the area of parallelogram FCDB is also 15 cm square. Its area is also 15 cm square because they are standing on the same base CD and between the same parallel lines AB and CD. Now the students, if there are many parallelograms standing on the same base and between the, suppose there are three parallelograms ACDE, FCDG, HCDB. There are three parallelograms which are standing on CD. It is the same base of these parallelograms. And these parallelograms are made between the same parallel lines AB and CD. In this case, the area of these parallelograms are equal, which are denoted by 1, 2, and 3. If the area of this first parallelogram is 20 cm square, then the area of second parallelogram is also 20 cm square. And the area of third parallelogram is also 20 cm square. The area of these parallelograms is same. The area of these parallelograms are equal because they are standing on the same base and between the same parallels AB and CD. They are formed between the same parallel lines AB and CD. So their areas are equal. This statement says this. Are you clear, the students? Now I am going to prove this statement. The parallelograms on the same base and between the same parallels are equal in area. How to prove this statement? We have given the parallelograms on the same base and between the same parallels. The parallelograms on the same base and between the same parallels are equal. Up to here it is given. Parallelograms on the same base and between the same parallels are given to us. We should prove or we should show their areas are equal. We should prove or we should show their areas are equal. In what case the area of the parallelograms are equal? The parallelograms which are standing on the same base and between the same parallels. We should show their areas equal. So now my students, let's make the parallelograms which are standing on the same base. Same base and between the same parallels. Here, two parallelograms ACDF. This parallelogram and the parallelogram ECDB are standing on the same base CD. According to the statement, parallelograms on the same base. The base of these parallelograms are same. The base of this parallelogram is CD. The base of this parallelogram is CD. Their base is same. Both parallelograms are standing on the same base CD. And between the same parallel lines, they are formed between the same parallel lines AB and CD. This parallelogram and this is another parallelogram. This. To prove this, at first we should write given. What is given to us? We should write one number given. What is given to us? We should write. We have given parallelograms on the same base and between the same parallels in the statement. According to the figure, parallelograms A, C, D, F and A, C, D, F and E, C, D, B. E, C, D, B. These parallelograms are standing on the same base CD. Both parallelograms are standing on the same base CD and between the same parallel lines. Between the same parallel lines, between the same parallel lines AB and CD. Parallelograms ACDF and ECDB. ACDF and ECDB are standing on the same base CD and between the same parallel lines AB and CD. It is given. Now to prove. What should we prove? If the parallelograms are standing on the same base and between the same parallel lines, then their areas are equal. Are equal in area. It means their areas are equal. We should show their areas equal. So to prove parallelogram, area of parallelogram or parallelogram, area of parallelogram symbol. This is the symbol of parallelogram. ACDF equals to the area of parallelogram by symbol parallelogram ECDB. To prove, we should prove the area of these two parallelograms are equal, or we should show the areas of these parallelograms equal. Now proof. We should give the proof. To prove this statements and reasons. To prove this, at first we should show this triangle and this triangle congruent. My students, do you know how to show the triangles congruent? We have some condition of the congruency of triangles. They are angle, side, angle axiom, side, angle, side axiom, side, side axiom, then angle, side axiom, and RHS axiom. RHS means right hand. RHS means right angle, hypotenuse and side. We have these conditions of congruency of triangles. If we show any one of these, then the triangles becomes congruent. Here we should show these two triangles congruent. Triangle ACE and triangle FBD. Now in triangles, let's take these two triangles. In triangle AEC and triangle FBD. In these two triangles, which axiom can we show in these two triangles? Let's try. In these two triangles, at first I think this angle equals to this angle. They are equal because they are corresponding angle. These two lines are parallel. AC and FD are parallel, and this is the transversal, and this angle are corresponding angles. So these angles are equal. In these two triangles, at first angle equal. Such figure is there. If we separate the figure, such is there. These two lines are parallel. These two lines are parallel, and this angle and this angle, these angles are corresponding angles. They are equal. They are the parallel lines. So these angles are corresponding angles. So they are equal. At first angle equal. Then after, this angle equals to this angle. They are also the corresponding angle. Here EC parallel BD. EC and BD are the parallel. They are the parallel lines, and this is the transversal, so they are corresponding angle, so they are equal. Another angle equal. Next, this side EC equals to BD. EC side and BD sides are equal because they are the opposite sides of the parallelogram. ECDB is a parallelogram. We know that the opposite sides of a parallelogram are equal. So EC equals to BD because they are the opposite sides of the parallelogram ECDB. So side equal. By the axiom angle, side. By the axiom angle, side, these two triangles becomes congruent. So my students, let's try to show them congruent. One number. At first, angle CAE equals to angle DFB. Angle DFB. Reason, corresponding angles. Corresponding angles. And in 2 number, angle AEC equals to angle FBD. Angle FBD. They are also the corresponding angles. 2 number. corresponding angles. This, and in 3 number we can show EC equals to FD. EC equals to FD. They are the opposite sides of the parallelogram. Opposite sides of parallelograms are equal. Opposite sides of a parallelogram. They are the opposite sides of a parallelogram, so they are equal. Look, this is at first angles are equal, second angles are equal, and third sides are equal. So by the axiom angles, angle, side, these two triangles are congruent. We have shown these two triangles congruent. By which axiom? By angle, angle, side axiom. So let's write triangle AEC, congruent triangle FBD by angle, angle, side axiom. By this axiom, the triangles becomes the congruent. Now in 3 number, after the congruency of triangles, we can write their areas equal. If the triangles are equal, if the triangles are congruent, then their areas are equal. Their corresponding sides are equal, their corresponding angles are equal, and their areas are equal. So we can write here area of triangle AEC or triangle AEC. Let's write area of triangle AEC. Area of triangle AEC equals to area of triangle FBD. Reason? What is the reason? The reason is area of congruent triangles are equal. Area of congruent triangles. Area of congruent triangles. After showing the congruent, their areas are equal. Area of congruent triangles. Area of congruent triangles are equal. So we wrote this. Then in 4 number, now area of triangle AEC. Now triangle AEC. Let's write triangle AEC plus. In this side, let's add this trapezium. In between these two triangles, look, there is a trapezium. ECDF. It is a trapezium because its one opposite sides are parallel. It is a quadrilateral in which one opposite sides are parallel, so it is a trapezium. Let's add this trapezium with this triangle. Let's add this trapezium with this triangle. Let's add the trapezium ECDF equals to, we added the trapezium ECDF in this side, then in this side also we should add the same, then they can be equal. So triangle FBD plus trapezium ECDF this. 4 number, adding the trapezium ECDF on both sides. on both sides. Now I remove this statement. Now 5 number, if we add triangle AEC and trapezium ECDF, this trapezium is added to this triangle, then this parallelogram becomes ACDF. When we add this trapezium with this triangle, what happens? It becomes the parallelogram ACDF. So the sum of these two, triangle ACE and trapezium ECDF, their sum becomes parallelogram this parallelogram or area of parallelogram ACDF equals to area of parallelogram next parallelogram ECDB 5 number reason from the statement 4 or whole part axiom from statement 4. Now it is proved. We proved the area of parallelogram ACDF equals to area of parallelogram ECDB. To prove area of triangle ACDF equals to area of parallelogram ECDB, it is proved. So at last we should write, hence the parallelograms on the same base and between the same parallels are equal in area. Now proved. Okay, thank you my students. If you have any comments and message, and if you have any curiosity, let's suggest me and comment.